We have now learned how to graph quadratic equations 3 different ways. And so I want to go over those, and then I'd also like to talk just a little bit more about stretches and shrinks at the end. So we have graph quadratics by standard form. Standard form again is y equals ax squared plus bx plus c. So this is standard form. The first thing we want to do is we want to find the vertex, and we're going to use negative b over 2a. Negative b over 2a to find the x-coordinate. Then we're going to draw the axis of symmetry. We're going to plot the y-intercept and its reflection point. We're going to pick an x value. And pick x values that are close to the axis of symmetry, right around where that vertex is, just on either side of that. And then find the y and then graph its reflection. So you're going to pick an x, find its y, and then graph its reflection. So that's all wonderful. It works out great. But as we found on the homework, sometimes things change. So what if the y-intercept is the vertex? Then you're going to pick an x value. You're just going to do the same thing as you did with step 4. Pick an x value right close to it, okay, right around where the vertex is and everything is. And you're going to find and then solve for y and do its reflection point. Okay. What if the y-intercept, because I say plot the y-intercept. Well, on one of the homework problems, we found out that the y-intercept was negative 51. Nobody wants to graph negative 51 on a grid that only goes to 10 to negative 10. So again, you can't use the y-intercept, so pick an x value. So both of these, if you don't have anything else that works, pick an x value. Okay, that always works. The next form we learned was vertex form, and we talk about the shifts. And what we want to do on that one is state what the shifts are. How does it open? Any stretches or shrinks? And we make note of those. Then we're going to plot the parent function, so y equals x squared. And we know we're going to plot those points. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Oops, probably about over there. So you're going to plot that parent function. Okay, and it was on a grid, you'd be able to see it better. Then we're going to apply the shifts. Okay, if there's any shifts like right 3, we're going to move all of these right 3 and down 1, or whatever. If there's a stretch or a shrink, we're going to figure out what the new y values are. I'm going to spend some time on that today. Now, the other option is you just plot the vertex. It's vertex form. You can just plot the vertex and then plot the parent function off the new axis. So if my vertex is up here, I can make a new axis over here, and then I can plot the vertex. I can plot the parent function right here. 0, 0, 1, 1, 2, 4, 2, 4. And we can graph it right there. Okay, so we have two options. Plot the parent function, use the shifts, or shift it first and then do the parent function. Again, stretch and shrinks, we're going to look at some more of those. So there's two options there. New axis, and see this above, this is talking about the stretches and shrinks. Okay, and then the third form we learned was factored form. And this one, first step, plot the x-intercepts. Then graph the axis of symmetry, which is halfway between the x-intercepts. Okay, that axis of symmetry gives you the x-coordinate of the vertex. Okay, and you can use that x value, then find the y value. Use the x value, plug it into the original equation, find the y value. Then you can plot the y-intercept in its reflection point, or you can pick an x value and find the y value and plot its reflection. So those are always options. You can always pick an x value. Now, the fourth option isn't really an option, but if in doubt, if you don't know what else to do, make a table. Make a table with x and y values. Pick the x values, okay, and then find out the y values. So if you have a function or an equation you don't know what to do with, make a table. That works for any function. Okay, so you'll have a copy of these too, or I'll post it on Schoology so you can refer to it. And this might be a handy thing. If you're good at keeping track of papers, this might be a handy thing to keep for next year or the year after, so that you have, how do I graph quadratics? Here are my 3 different ways that I can graph them. Okay, so I want to go back. This is what we're going to get to for homework. I want to go back to page 19 in your packet, and it's this worksheet right here, Graph Quadratic Equations Worksheet. Okay, find that. But I want to go to the back. And I'm going to pick number 5 to begin with. Nope, I'm going to pick number 7. So we're going to look at pick number 7. And the reason I want to look at that is because of this stretch right here. So let's start it off the same way. We're going to do this. This is vertex form. And what do you notice your vertex is? That's always a good idea to state our vertex. If I'm in vertex form. My vertex is going to be 2, 0, because there's nothing out there. So let's look at our shifts. Remember, our shifts and our vertex are going to match up. So this is going to shift right 2, and then it doesn't shift anything up and down. So right 2. But we have a stretch of 3. Okay, now the order in which you do these, totally optional. I don't always know which is the best order to do it in. Do I plot the parent function, stretch it, and then move it? That's probably what I would do. But it also depends on if I'm going to flip it or not. So sometimes that makes a difference too. So here we go. I'm going to plot the parent function. I like that as a start. So 0, 0, 1, 1, negative 1, 1, 2, and 4. Remember, if you forget this, just take that x value and square it. That's all the parent function is. Okay, now the stretch. What I like to do for the stretch is I like to say, what is my current y value? What is it going to be with a stretch of 3? Okay, so my current y value is 1. I'm going to multiply it by 3 to get my new y value. So this point right here, that is 1, 1, and I'm not even talking about the shifts. That will come. I'm going to do my stretch first. I'm going to take this point that becomes, the y value now becomes 3. So this point becomes 1, 2, 3, goes right there. So my parent function shifts. Of course, this point isn't going to shift. It's not going to stretch because it's 0, 0. And of course, the reflection point. If I have this point that has a y value of 4, 4 times 3 is 12. So this point, this is how much the stretch works. This point goes all the way to 12. Here's 4, 5, 6, 7, 8, 9, 10, 11, 12. It's approximately where it goes. So my parent function looks like this. Okay? Now my parent function are the blue dots. Now I'm going to do this right 2 thing. Okay? One more color. So I'm going to move everything right 2. So 1, 2. I'm going to move 1, 2. 1, 2. Now that one takes over that point. Okay, that point gets taken over. This one goes 1, 2. This one goes 1, 2. So my function, my graph, my final graph looks like this. Okay, so what I like to do is make a little table of my stretch. But all I did is I wrote down the y values of the parent function, and then I shift it. So I do like to stretch and then shift, I guess. Okay, let's look at number 8. Let's write down our shifts. Okay, how does this shift? Right 1. And what about this shift? Down 4. But we also have a stretch of 2. Okay, stretch of 2. So that means I'm going to have this little table right over here. And I'm going to do my stretches in just, not my stretches. We're going to stretch this parabola. So plot the parent function. 1, 1, negative 1, 1, 2, 4, 2, 4. There's my parent function. Now we're going to do a stretch. So if I do a stretch on this, okay, my y values are 1. Well, I have 0, 0. That doesn't go anywhere. 1, 1. So 1 times 2. This is a stretch of 2. That's going to be 2. That's this point. So this point goes up to here. Okay? And there's this reflection point. You know what? I'm going to put those with x's so then you kind of know what's the change. So this one's stretched here and here. If I have a y value, so for this point, I'm going to take 4 times 2, I'm going to get 8. So 4, 5, 6, 7, 8. So my x's are where it's stretched to, and that's what I should have done before. That's my stretch. Now I'm going to apply the shifts. So now I'm going to shift 1. Everything's going to shift 1. Okay, shift 1, down 4. I better start at the vertex so I keep track of it. I'm going to go right 1, down 4. 1, 2, 3, 4. Right 1. Now I go from this stretch point, right 1 and down 4. 1, 2, 3, 4. Right 1, down 1, 2, 3, 4. Right 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. there's my graph. Okay, let's look for another one that we have to flip on. Now on page 27 in your packet, and we're looking at Vertex Form. Vertex Form. And I would like to start trying to find the, oh, there it is. Okay, look at this one. We have a stretch, we have a flip, and we have shifts. This thing has everything. So let's go through this. And it kind of tells us right here, is this going to be wide or narrow? Well, this one's going to be narrow because it's a whole number. And we know that it's going to translate. This is up and down, so it's going to go up 3. This tells me I'm going to go, it's a positive, so it seems I should go to the right, but I'm going to go to the left, and I'm going to go to the left 2. The thing that it doesn't talk about is that I'm also going to open, I know maximum I'm going to do it, but it helps me if I just write down opens down. Okay? And there's also a stretch of 2. Okay? Vertex acts as a symmetry. Oh yeah, we can write the vertex. What's my vertex? Look at your shifts. Okay? Left 2, that's a negative 2. Up 3, that's a positive 3. Acts as a symmetry is always x equals whatever the x coordinate is. Okay, so we know all that. What I like to do on this one is I'm going to do a couple different things. One, I'm going to do the parent function, 0, 0, 1, 1, 1, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. But now I'm going to flip it. So I'm going to flip it next. It opens down. So now this stays, but I'm going to change all my points down below. So I'm going to go down over 2, write 1, 2, 3, 4. Over 2, down 1, 2, 3, 4. Okay, so this is it opening down. Now I have a stretch of 2. Isn't this fun? Okay, so we have y, and our y values are -1, okay, y values, and -4. So if I have a stretch of 2, I'm going to take this times it, so I get -2, -8. So this point now goes all the way up to -2. And this one goes up to -8. This is very similar to the one we just did. 1, 2, 3, 4. Oh, wait. 4, 5, 6, 7, 8. Sorry about that. Okay, and this one comes up here. So the orange ones are now what the stretch is. Now we get to do the shifts. It just doesn't seem to get any better. We just keep adding things to it. This is so cool. Okay, so let's add that to it, and we're going to shift everything. So my vertex is going to go up 3, 1, 2, 3, and then it's going to go left 2, 1, 2. Here we go. This one. Up 3, 1, 2, 3, over left 2. Okay? So we're going to go up 3, 1, 2, 3, over 2. And this one goes up 3, 1, 2, 3, over 1, 2. 1, 2, 3, over 1, 2. Now your axis of symmetry, doesn't hurt to draw that in. See that? That's where your axis of symmetry is. So your graph is right here. Okay? So that just gives you an idea when you have to flip it and stretch it and everything else. I just wanted to show you one of those. Okay. So I don't want to keep you too long. If you were in class, I would love that, because then we could go over any that you had questions on. I could make some up. These are ones I can make up. So now going back to the different ways that we can graph. Okay, this one's standard form. So for standard form, look at your steps. You're going to find the vertex. Use -b over 2a. Okay, so we're going to use -b over 2a to find our x-coordinate of our vertex. And we're going to find the axis of symmetry. This is really helpful. This not so much so. Okay, because translating is only helpful if you have if you actually can see how it translates. This one we can't do that right now. Okay, you can decide if it's wide or narrow. Not even that. Although a is 2, so it's probably going to be narrow. It is. It's going to be narrow. Okay, that one's going to be narrow because that a still does the same thing. How does it open? It opens up. Up. So if it opens up, that means I'm going to have a minimum. Okay. And domain and range, I'm not worried about those right now. So find your y-intercept. That's the one thing I don't like about this, how this one's written. Find your y-intercept. You always want to find your y-intercept. Okay, so follow those steps so you have those in front of you. And then this one is vertex form. So vertex form, you're going to state the shifts. How does it open? What are the stretches and shrinks? Plot the parent function. Apply the shifts and the stretches and the shrinks. Okay. This one is intercept form. And notice the stretches on these, they work themselves out because you're picking points and you're picking your y-intercept. Stretches and shrinks on these work themselves out also. So this one is the only when you're given vertex form do you have to do that thing with the stretches and the shrinks. Okay, but remember on any of these, you could always just make a table. Good. You're going to do the same thing on the back with all of those. So hopefully that's the advantage if you're in class or if you come to class. If you're the online students, if you come to class, then you can pick which ones. We could do some together. So that's it for the 3 ways. Reviewing the 3 different ways that we learned this week, and hopefully that helps some. If you have any questions, you know where to find us. Thanks so much.